Welcome to EDU World Space.
Next question here said, if the core electron were totally effective in screening the valence electron, and the valence electron provide no screening for each other, what would be the effective nuclear charge acting on the 3s and the 3p valence electron in P? So in this exercise, we have to answer what would be the effective nuclear charge acting on the 3s and the 3p valence electron in P if the core electrons were totally effective at shielding the valence electron, and the valence electron provide no shielding for each other. So we assume P to have a atomic number 15, which is phosphorus. It's not even an assumption, it's what it is, phosphorus 15. And the electronic configuration of that is 1s2, 2s2, 2p6, 3s2, 3p3. Okay? And we can just assume that this is similar to this, or not even assume. We just want to write it in the form of the core electron configuration, or where you have the noble gas followed by the rest of the electron in their respective orbitals. So there are 10 core electrons. So 10 core electrons. Okay. And the Z effective for 3s electron, Z effective for 3s electrons will be Z minus S. And that will be equals to, the atomic number is Z, and that's 15 minus S. S is the screening constant, so that's 10 multiplied by 1. And that is 15 minus 10, and that is plus 5. So 3s and 3p have equal effective nuclear charge of plus 5. So the next question said that detailed calculation indicates that the effective nuclear charge is 5.6 positive for 3s and 4.9 positive for 3p. Why are the values for the 3s and the 3p different? So I said 3s has Z effective equals to 5.6 positive, and 3p has Z effective to be equals to 4.9 positive. So why are these two different from what we calculated? So we have to answer why are the values for the 3s and the 3p electrons different. So the values for the 3s and the 3p electron are different because the penetration of the 3s orbiter is more than the penetration of the 3p orbiter. And that is why the effective nuclear charge for the 3s electron is more than that for the 3p. So this is 3s orbiters is more penetrating. And because of that, it gets more shielded, more penetrating. It's more penetrating, this should be 10, than 3p. And because of that, it gets more shielded than the 3p. And that will lead to the increase in the effective shielding, nuclear charge for the 3s. So the next question said, if we remove a single electron from the p atom from phosphorus, so if we have 15 phosphorus and then we remove one electron, we're going to have, uh, of course, 15 phosphorus, but now with 14 electrons. And here we have 15 electron. So the question is asking us where the electron will be removed from. Of course, the electron will be removed from the p orbiter. So the electron will be removed from the p orbiter because the p orbiter is less shielded, and that is the 3p to be specific, than the 3s.